what is the meaning of increasing / decreasing functions, and a few fallacies that follow with increasing and decreasing functions. Chalo. So an increasing function, let's talk about increasing function first. An increasing function is a function which is fa minus fb will be positive if greater than equal to 0, if a is greater than equal to b. This is the meaning of an increasing function. Strictly increasing function is when fa minus fb is positive whenever a is greater than b. Okay. Increasing function is fa minus fb greater than equal to 0 when a is greater than equal to b. Strictly increasing is when fa minus fb is positive when a is greater than b. Similarly, we have the definition of a decreasing function. Fa minus fb less than equal to 0 when a is greater than equal to b. Strictly decreasing is fa minus fb is negative when a is greater than b. ठीक है? पहला वाला क्या बोल रहा है that when a is greater than b, then fa minus fb is positive. Okay, strictly increasing के लिए. Increasing के लिए fa minus fb greater than equal to 0 when a is greater than equal to b. ठीक है? That is the function is increasing, right? Decreasing fa minus fb less than equal to 0 when a is greater than equal to b. Strictly decreasing fa minus fb less than 0 when a is greater than b. Okay, now this is the crux of increasing and decreasing, right? Now, can anyone tell me that by calculus, how will you be able to find out whether a function is increasing or decreasing? By calculus, equal to 0, if a function is increasing and as well as decreasing, it means that it's a constant function. Because if fa minus fb greater than equal to 0 when a is greater than equal to b, and fa minus fb is less than equal to 0 when a is greater than equal to b, if I combine the definition of increasing and decreasing, it basically means that fa minus fb is equal to 0 when a is greater than equal to b. That means that the function f is a constant function. समझ में आया? Okay. Right. Now, with respect to derivative, what can be said? If you are told that I have a function which is strictly increasing, okay?
Yes.
Yeah. So if I tell you that a function is strictly increasing, sorry, what can be said about the derivative? This is incorrect. Let me tell you why. Strictly increasing function, let's take an example. X cube is a strictly increasing function. Do you agree with me? See, whenever fa minus fb I take, and a is greater than b, okay, a cube minus b cube will be strictly greater than 0. So x cube is a strictly increasing function. What can be said about the derivative of x cube? What is it equal to? 3x square. Can this ever be equal to 0? This is equal to 0 for x is equal to 0, right? So even though a function is strictly increasing, it can have the derivative to be equal to 0 for some x. Strictly increasing does not guarantee f dash is greater than 0. Can you tell me logically why is this happening? How do you get for a strictly increasing function the derivative to be equal to 0 at some point? Why is this happening? Can you tell me logically? Okay, let me give you a hint. At x cube, you take a look at the graph of x cube. Okay, let me help you with the graph. Maybe that will give you a hint. So I draw the graph of x cube. What do you notice at x is equal to 0 for x cube? For a strictly increasing function, the derivative can be equal to 0 if it is a point of inflection, right? And this is a mistake that many students make. Strictly increasing function, they will always say f dash is greater than 0 for all x. Answer is f dash is greater than equal to 0 for all x. It is a possibility that it is greater than 0. It is a possibility. Like, for example, if I have e to the power of x, this is also a strictly increasing function. But when I take a look at the derivative, it is e to the power x, which is strictly positive. Okay, it's not a hard and fast rule that a strictly increasing function will always have the derivative at some point to be equal to 0. But I am saying that if I say that strictly increasing function will always have the derivative positive, that is also incorrect. There can be a few strictly increasing functions where the first order derivative is equal to 0 for some x. There can be a few strictly increasing functions where the first order derivative is equal to 0 for some x. And the characterization of the point where the derivative is equal to 0 is a point of inflection. Okay, so whenever I have a strictly increasing function having a point of inflection, it can be that the derivative is equal to 0 at that point. Okay. Similarly, a strictly decreasing function as well. Similarly, a strictly decreasing function will always give us this definition less than equal to 0 for all x. Okay, right? Again, an example here will be opposite, minus x cube. Minus x cube, you can see this will be a strictly decreasing function, and the derivative is equal to 0 again for x is equal to 0. Okay, that's an example of a strictly decreasing function where the derivative is equal to 0 for some x. Again, for minus x cube, x is equal to 0 is a point of inflection. Okay. However, here we were taking a look at increasing means f dash greater than equal to 0, decreasing means f dash less than equal to 0. Okay. Strictly increasing was meaning this, strictly decreasing is meaning this. However, there is something, now please don't get confused, I'm giving you some theory together, right? So if ever they mention that I have a function such that f dash is greater than 0 for all x. Okay, they can say this, there is a function f such that f dash is greater than 0 for all x. What kind of a function will this be? If they mention in the question that f dash is positive for all x, it means that the function is strictly increasing. But it is now important for you to understand that f dash positive means this, but strictly increasing does not mean this. It's not vice versa. So f dash positive for all x will mean strictly increasing. Strictly increasing will not mean f dash positive. Okay. Similarly for strictly decreasing. So if f dash is negative for all x, it will imply strictly decreasing, but as we have seen, not vice versa. Okay. Strictly increasing and strictly decreasing is a very interesting concept which many students confuse themselves in. Okay, this is a concept where you need to introspect a little bit. एक बार इसको समझ में आ गया, then you will never forget it. That is the beauty of this. So one time you need to really understand the concept. Okay, and the same can be easily done